settle into the sleepy mind channel. Tonight, we will explore the hidden knowledge of ancient ethnobotany and the remarkable relationship between human beings and the plant life surrounding them across history. If you enjoy calm educational sleep stories like these, feel free to like and subscribe. More videos are posted weekly. You can also explore the playlists filled with long, relaxing stories about history, nature, science, lost worlds, space, and ancient civilizations designed for all-night listening. Long before written history, before cities rose from stone, and before science developed laboratories or modern medicine, human survival depended almost entirely upon understanding the natural world. Ancient people lived among forests, rivers, grasslands, mountains, and deserts, filled with thousands of plant species, each carrying hidden properties that could nourish, heal, strengthen, poison, shelter, or protect. Over many generations, people learned which plants could ease pain, which roots could provide food during difficult seasons, which fibers could become rope or cloth, and which trees could survive harsh weather while forming strong shelters and tools. What makes this ancient knowledge so fascinating is that much of it developed without books, writing, microscopes, or chemistry. People learned through observation, memory, experience, and survival itself. Every plant carried uncertainty at first. Some could support life, while others could bring sickness or death if used incorrectly. Early humans therefore became careful observers of nature because their lives depended upon recognizing patterns hidden within the environment around them. Imagine standing inside a dense ancient forest without modern knowledge of the plants surrounding you. Every leaf, vine, flower, bark-covered trunk, and cluster of berries would represent possibility mixed with danger. Ancient people faced that uncertainty every day. A single mistake could bring severe illness, while a useful discovery might support an entire community through winter or drought. Knowledge became one of the most valuable resources human beings possessed, because understanding nature often meant the difference between survival and suffering. Over long stretches of time, people began noticing repeating patterns. Certain plants appeared useful for wounds. Others eased stomach pain or helped preserve food. Some woods resisted moisture better than others, while certain fibers proved stronger when twisted into rope or woven into cloth. Gradually, experience transformed uncertainty into practical understanding. Human beings uncovered a hidden biological world growing quietly all around them. This relationship between humans and plants shaped nearly every aspect of early civilization. Plants provided food, medicine, shelter, tools, baskets, dyes, fuel, oils, fibers, and building materials. Entire communities depended upon seasonal plant cycles and local ecosystems. Even the locations where people settled were often influenced by reliable access to useful plant life and fertile environments. Ancient ethnobotany shows how connected observation became with survival. Long before modern science existed, people were already studying biology in practical ways, simply by paying close attention to the effects plants produced. A bitter-tasting root might contain powerful active compounds. Aromatic leaves could repel insects. Certain bark preparations eased discomfort, while some berries caused dangerous reactions. Ancient knowledge developed slowly through repeated experiences spread across many generations. People also observed animals carefully. Early humans may have watched birds, deer, primates, and other animals interacting with plants throughout changing seasons. Certain species appeared to avoid specific plants, while others repeatedly consumed them during illness or migration. Observation became one of humanity's earliest scientific tools, long before formal science itself existed. This knowledge did not appear instantly. It accumulated gradually through patience and memory. Every generation inherited observations gathered by the people before them, then added new discoveries through direct experience. Over time, ancient communities developed surprisingly detailed understandings of local plant life without ever viewing cells, molecules, or chemical formulas. Plants themselves are remarkably complex living organisms. Beneath the surface of leaves, stems, roots, and flowers exist countless chemical compounds created through biological processes, refined over millions of years. Some compounds protect plants from insects, while others influence taste, scent, color, or growth. Ancient people lacked modern scientific language for these compounds, yet they recognized that different plants produce different effects within the human body and environment. Experience shaped how plants were used within different regions of the world. A community surviving within a cold northern forest developed different knowledge from people living beside tropical rivers or dry desert landscapes. Geography influenced available species, while climate shaped how plants grew, reproduced, and survived. Human cultures adapted themselves to the natural resources surrounding them. This connection between nature and culture became deeply woven into daily life. Plants influenced food traditions, healing practices, construction methods, clothing materials, spiritual customs, trade routes, and even early systems of agriculture. Human civilization grew alongside plant knowledge in ways that still influence the modern world today. Modern science still studies many plants first used by ancient cultures. Researchers now analyze active compounds using chemistry and biology, often confirming observations ancient people discovered through direct experience alone. The connection between past and present remains surprisingly strong because plants continue supporting medicine, agriculture, nutrition, and industry across the modern world. The hidden knowledge of ethnobotany therefore reveals more than ancient survival techniques. It reveals one of the oldest relationships in human history. Across forests, mountains, valleys, rivers, and deserts, people learn to read the natural world around them through careful lived experience. Plants became food, medicine, shelter, tools, dyes, fibers, symbols, and companions within the long development of human civilization. Inside every ancient landscape where people once gathered leaves, roots, bark, seeds, and wood beneath changing seasons, knowledge quietly accumulated generation after generation. Through patience, observation, and survival itself, human beings uncovered the remarkable biological properties hidden within the plant life surrounding them, shaping the course of culture, medicine, technology, and daily life across thousands of years of history. Long before written records existed, nearly all important knowledge survived through memory, storytelling, repetition, and direct teaching between generations. Ancient plant knowledge was not stored inside books or libraries. Instead, it lived inside communities themselves. Elders remembered which plants could heal illness, which roots remained safe during famine, which bark produced strong fibers, and which berries needed to be avoided entirely. Survival often depended upon preserving this knowledge carefully, because forgetting even a small detail could carry dangerous consequences. In many ancient societies, knowledge was treated almost like a living inheritance passed from one generation to the next. Children learned gradually by observing parents, grandparents, healers, builders, gatherers, and craftspeople working with plants during ordinary daily life. Information was repeated constantly through routines connected to gathering food, preparing medicine, weaving fibers, building shelters, or traveling through forests and grasslands during changing seasons. Imagine a quiet evening beside a fire long ago. Older members of a community carefully sort leaves, roots, bark, and seeds collected earlier that day, while younger people sit nearby watching closely. A certain root may only be harvested during a specific season. A leaf might need drying before use. Another plant may appear harmless at first glance, but become dangerous if prepared incorrectly. Every instruction matters because the knowledge carries practical importance connected directly to survival. This type of teaching required patience and memory. Ancient people could not search for information instantly or record every observation with written notes. Instead, useful knowledge became connected with repetition. The same plant lessons might be shared hundreds of times across many years until younger generations remembered them naturally through experience and familiarity. Oral traditions also helped preserve accuracy. Stories, rituals, songs, repeated phrases, and demonstrations allowed communities to remember complicated information for remarkably long periods of time. In some cultures, plant knowledge became connected to seasonal ceremonies, spiritual customs, or family traditions because these social structures helped protect important information from being forgotten. Plants therefore became more than practical resources. They became part of cultural identity itself. A community living within a dense rainforest would develop different traditions from people surviving beside dry grasslands or cold northern forests. Geography shaped available plants, while local experience shaped how knowledge evolved over time. Observation remained one of the most important parts of this process. Ancient people carefully watched how plants changed during different seasons, how weather influenced growth, and how preparation altered effects. They learned which species thrived near rivers, which survived harsh winters, and which became useful only after drying, heating, grinding, or soaking. Over generations, these observations formed detailed systems of practical understanding adapted to specific environments. One reason this knowledge became so valuable was because plants often look deceptively similar. Safe and dangerous species could grow side by side within the same forest or valley. Ancient communities therefore relied heavily upon careful identification and repeated teaching. Small visual differences in leaf shape, smell, texture, or color might completely change whether a plant could safely be used. Traditions helped preserve these distinctions. Certain gathering methods became standardized within communities because experience had proven them reliable over many generations. Some plants may have only been collected during particular seasons when their effects were considered strongest or safest. Others may have required careful preparation before becoming useful. Knowledge also changed gradually through experience. Ancient people were not frozen within unchanging traditions. New observations continued influencing how plants were used. Communities adapted their practices when environments shifted. New plants appeared through migration or trade, or different preparation methods produced better results. This gradual improvement of understanding resembles the slow development of science itself. Long before formal biology or chemistry existed, ancient humans were already testing observations against lived experience. A plant producing reliable results would continue being used while ineffective or harmful practices might eventually disappear over time. In many regions, certain individuals became especially skilled at remembering plant knowledge. Healers, gatherers, herbal specialists, builders, and craftspeople often developed detailed familiarity with local species and their properties. Their experience carried enormous importance because they preserved practical understanding, benefiting entire communities. The relationship between memory and survival therefore became extremely strong within ancient ethnobotany. Forgetting important details about useful or dangerous plants could create serious problems. Oral teaching helped communities maintain continuity across generations while adapting slowly to changing environments. Trade and travel also influenced how knowledge spread. As people moved between regions, they encountered unfamiliar plants and exchanged useful information with other communities. Over time, ideas about medicine, fibers, dyes, food preparation and cultivation traveled alongside human migration and trade routes. How detailed some ancient plant knowledge became despite the absence of modern scientific tools. People identified subtle differences between species, recognized seasonal patterns affecting potency or usefulness, and developed preparation methods refined through generations of experience. Much of this understanding emerged simply through careful attention to nature itself. Human life remained connected to these traditions because plants supported nearly every part of daily survival. Food, medicine, shelter, tools, baskets, textiles, oils, dyes, fuel, and trade goods all depended heavily upon preserving reliable botanical knowledge across generations. Even today, traces of these oral traditions survive within many cultures around the world. Certain remedies, farming practices, gathering methods, and plant customs still reflect knowledge accumulated slowly through countless generations of observation and lived experience. Modern science often studies plants first valued by ancient communities long before laboratories existed. Across forests, valleys, mountains, deserts, and river systems throughout human history, plant knowledge traveled quietly from voice to voice, hand to hand, and generation to generation. Through memory, repetition, patience, and careful observation, ancient people preserved a hidden understanding of the natural world that shaped survival, culture, healing, and daily life for thousands of years. As ancient communities spent generations observing the natural world, certain plants gradually became associated with healing, comfort, recovery, and relief from illness or injury. Long before hospitals, pharmacies, or written medical systems existed, people turned toward leaves, bark, roots, flowers, seeds, and sap in hopes of easing pain and supporting the body during sickness. Some preparations proved surprisingly useful, while others produced little effect or even caused harm. Over long periods of trial, memory, and observation, ancient humans slowly built some of the earliest forms of practical medicine from the plant life surrounding them. The process often began with direct experience. A crushed leaf placed against irritated skin may have reduced discomfort. A bitter root consumed in small amounts might have eased stomach problems. Bark soaked in water could produce calming or numbing effects. Ancient people carefully remembered these results because successful treatments quickly became valuable knowledge within the community. Imagine living in a world without manufactured medicine, refrigeration, antibiotics, or modern surgery. Even small injuries could become serious problems. Illness, infection, fever, or digestive sickness carried far greater danger than many people experience today. Under those conditions, discovering even modest relief from a useful plant would have seemed incredibly important. Knowledge about healing plants therefore became deeply respected because it directly affected survival and quality of life. Many ancient remedies relied upon different parts of the same plant being prepared in different ways. Leaves may have been crushed into pastes, while roots were dried and ground into powders. Bark could be soaked, heated, or boiled slowly in water to release certain compounds. Seeds and flowers sometimes required careful preparation before use. Ancient people realized that the method of preparation often changed how a plant behaved. Roots became especially important in many early healing traditions because they often contained concentrated compounds produced by the plant beneath the soil. Digging roots required effort and knowledge because some species looked nearly identical while carrying completely different effects. Careful identification therefore remained extremely important. Bark also played a major role in ancient medicine. The outer protective layers of trees contain many chemical substances produced by the plant for defense and survival. Ancient people observed that certain bark preparations affected pain, fever, digestion, or skin irritation in noticeable ways. Over generations, some tree species became strongly connected with healing practices inside specific cultures. Leaves were often easier to gather and prepare quickly. Fresh leaves might be crushed directly onto wounds or soaked in water to create simple extracts. Aromatic leaves containing strong oils sometimes became associated with cleansing, preservation, or relief from discomfort. Ancient communities likely experimented constantly with the plants available in their local environments. Early plant medicine is that ancient people recognized effects long before understanding the biological reasons behind them. They did not possess microscopes or chemical formulas explaining why certain plants worked. Instead, knowledge developed through repeated observation of practical results. This resembles the earliest stages of scientific reasoning. A treatment producing consistent improvement would continue being used while dangerous or ineffective preparations might eventually disappear through experience. Ancient medicine therefore evolved slowly through generations of careful trial and memory. Extracts became one of the most important developments in early ethnobotany. Ancient people learned that soaking, crushing, grinding, heating, or boiling plants could release hidden substances from inside the material itself. Water, oils, or animal fats were sometimes used to draw compounds out of bark, roots, or leaves during preparation. These extracts often produce stronger or more concentrated effects than the raw plant material alone. Although ancient people lacked modern chemistry, they clearly recognized that plants contained active substances capable of influencing the body in different ways. Some compounds affected digestion, while others influenced pain, energy, relaxation, breathing, skin irritation, or sleep. Certain plants may have appeared useful in small amounts, yet dangerous in larger quantities. Ancient communities learned that dosage mattered greatly, even if they described it through practical experience rather than scientific measurement. Different environments also shaped healing traditions. A desert community developed knowledge based upon dry climate plants, while rainforest cultures relied upon entirely different species growing within humid ecosystems. Geography therefore influenced medicine just as strongly as culture and tradition. Plant medicine was rarely separated completely from daily life. Gathering healing plants often occurred alongside collecting food, fibers, wood, or fuel. The same landscape providing shelter materials and nutrition also supplied treatments for illness and injury. Nature became both pharmacy and survival system simultaneously. Over time, some communities developed highly detailed systems of plant preparation and classification. Certain plants may only have been gathered during specific seasons, while others required drying before use. Some preparations were considered safe only for adults, while others were reserved for particular illnesses or conditions. This growing body of knowledge reflected humanity's increasing awareness that plants contained hidden biological properties capable of affecting the human body in powerful ways. Ancient people may not have understood molecules or receptors, yet they clearly recognized that nature itself carried medicinal potential. Modern science continues confirming many observations first discovered through ancient ethnobotany. Researchers now study active plant compounds using chemistry, pharmacology, and biology, often identifying substances responsible for effects noticed by traditional healers centuries or even thousands of years ago. Across forests, valleys, mountains, and grasslands through history, people uncovered a remarkable hidden relationship between plants and human health. Through observation, preparation, patience, and experience, leaves, bark, roots, and extracts became some of humanity's earliest medicines, shaping survival and healing long before modern science began explaining the biological processes hidden inside the natural world. As ancient people continued experimenting with plants over time, they slowly began recognizing that certain preparations produced reliable and repeatable results. Some remedies appeared helpful for pain, while others eased digestive discomfort, reduced swelling, soothed skin irritation, or encouraged rest during illness. Through observation and repeated experience, early plant medicine gradually became more organized and practical, rather than random experimentation alone. This process likely unfolded across ordinary moments, spread through many generations. A healer may have noticed that a particular bark preparation repeatedly reduced fever. Another community may have discovered that one root worked better when dried before use rather than consumed fresh from the soil. Over time, useful observations accumulated into larger systems of understanding. Imagine standing beside a fire while someone carefully prepares the same plant remedy that parents and grandparents had used before them for many years. The process itself would carry memory and trust, because earlier generations had already observed its effects repeatedly. Ancient medicine therefore became connected with continuity and experience rather than isolated discoveries. Selection played a major role in this development. Plants producing beneficial effects consistently were more likely to remain important within healing traditions. Preparations causing severe illness or dangerous reactions may eventually have been avoided or restricted through repeated negative experience. In this way, observation slowly guided the evolution of practical medical knowledge. People also learned that preparation methods could greatly influence outcomes. A leaf crushed fresh might behave differently from the same leaf after drying. Roots boiled slowly in water could release stronger effects than raw pieces eaten directly. Oils, heat, grinding, fermentation, and soaking all altered how plant compounds interacted with the body. This gradual refinement resembles a slow form of biological experimentation unfolding over generations. Ancient healers did not possess controlled laboratories or scientific terminology, yet they still relied heavily upon patterns, consistency, and observed results. Useful knowledge survived because communities remembered what appeared effective and repeated it carefully. Early medicine is how closely connected it remained to the natural environment itself. Healing knowledge depended upon seasons, geography, climate, and local ecosystems. A mountain community would develop different remedies from people living beside tropical wetlands or dry desert valleys because entirely different species surrounded them. The same plant might also produce different results depending upon soil conditions, climate, age, or harvest timing. Ancient people gradually recognized many of these differences through practical experience. Certain plants may only have been gathered during specific months, because that period produced stronger or safer effects. Biology itself shaped these outcomes in ways ancient people could observe, even without understanding the hidden chemistry involved. Plants contain active compounds produced through their own survival processes. Some compounds discourage insects, while others influence scent, bitterness, or defense against disease. When humans consumed or prepared these substances, noticeable effects sometimes followed. Ancient communities likely recognized that different plants carried distinct personalities or characteristics. One herb may have produced calming effects, while another increased alertness or warmth. Certain preparations soothed the skin, while others affected digestion or breathing. Over time, these observations became organized into practical healing systems adapted to local conditions. Some remedies were probably mild and comforting, while others carried significant risk if used incorrectly. Ancient people learned that dosage mattered greatly. A small amount of one plant might help the body, while larger amounts could become dangerous. Experience therefore guided not only which plants were useful, but also how much should be prepared and consumed. Knowledge improved gradually because people continued learning from success and failure alike. A treatment helping one illness but worsening another would eventually shape future decisions. Communities refined methods constantly through lived experience across generations. This slow accumulation of knowledge forms one of the foundations of ethnobotany itself. Ancient medicine did not emerge from isolated genius alone. It developed collectively through thousands of observations repeated by ordinary people interacting with the natural world every day. Plants therefore became more than passive materials gathered from forests and fields. They became active participants in early healing traditions. Human beings learned to recognize subtle biological properties hidden inside roots, bark, flowers, seeds, and leaves through direct contact with nature itself. How much ancient people achieved without modern scientific equipment? Through observation alone, they identified plants capable of producing powerful physical effects. Many traditional remedies eventually inspired modern scientific investigation centuries later when researchers began isolating active compounds using chemistry and pharmacology. The connection between biology and medicine slowly became clearer through experience, even if ancient communities described it differently from modern science. People recognized that the human body responded differently to different plants, because those plants contained hidden natural substances capable of influencing health and physical sensation. Healing traditions also strengthened social bonds inside communities. Knowledgeable healers often became respected figures because their experience carried real practical importance. Families depended upon people capable of identifying useful plants and preparing treatments safely during illness or injury. Nature therefore supported health in ways extending far beyond simple nutrition. Forests, riversides, grasslands, mountains, and wetlands all contained living chemical systems, quietly producing compounds that ancient humans learned to use through patience and observation. Across thousands of years of human history, early medicine evolved through many small discoveries connected directly to the natural world. Through repeated experience, careful preparation, and observation of results, ancient people gradually transformed plant knowledge into practical systems of healing that shaped survival, culture, and the earliest foundations of medicine, long before modern biology began revealing the hidden chemistry inside the plants themselves. As ancient people continued using plants for healing, food, and daily survival, they gradually discovered that many plants could influence the human body in surprisingly noticeable ways. Some preparations reduced discomfort, while others increased alertness, encouraged relaxation, altered digestion, or affected breathing and energy. Ancient communities may not have understood the chemistry hidden inside these plants, yet through repeated observation, they clearly recognized that certain species contained powerful natural substances capable of producing real physical effects. Modern science now understands that plants create many chemical compounds as part of their own survival processes. Some compounds discourage insects, while others protect against disease, regulate growth, store energy, or influence scent and flavor. Ancient people could not see molecules or analyze chemical structures, yet they still learned that plants were far more biologically active than they first appeared. Imagine walking through an ancient forest where nearly every leaf, root, flower, and seed contains hidden chemistry invisible to the human eye. Some plants produce bitter compounds that discourage animals from eating them. Others release aromatic oils into the air. Certain species create pigments, toxins, sugars, acids, or stimulating substances as part of their natural biology. Ancient people uncovered this hidden chemical world simply by interacting with plants over many generations. Ethnobotany is that ancient humans recognized effects long before understanding their biological causes. A root causing numbness or warmth would become associated with those effects through memory and repetition. A calming herb used before sleep might slowly gain importance within healing traditions because people repeatedly noticed similar outcomes. This gradual recognition of plant effects became one of humanity's earliest encounters with practical biology. Ancient communities learned through direct experience that substances inside plants could interact with the body in different ways depending upon preparation, amount, and individual response. Some compounds affected digestion, while others influenced pain, circulation, skin irritation, breathing, or energy levels. Certain leaves may have soothed inflammation when crushed onto the skin, while bitter bark preparations influenced fever or discomfort. Ancient people lacked scientific language for receptors, enzymes, or nervous systems, yet they observed clear patterns connecting specific plants with specific physical reactions. Dosage quickly became extremely important. A small amount of a useful plant might produce mild, helpful effects, while larger amounts could become dangerous. Ancient communities therefore learned caution through experience. Preparation methods, timing, and quantity all influenced outcomes in significant ways. Imagine a healer carefully measuring dried roots by sight and memory, because generations of observation had taught that too much could cause harm, while too little might produce no noticeable effect. Long before laboratory measurements existed, practical experience guided how plants were prepared and consumed. Some plants likely appeared mysterious because their effects seemed unusually strong compared with ordinary food. A tea prepared from certain leaves could calm the body, while another preparation increased alertness or affected perception. Ancient people learned that the natural world contained substances capable of influencing the mind and body in remarkably different ways. This understanding developed gradually through repetition and observation. Communities shared information about safe preparation methods, dangerous reactions, useful combinations, and seasonal changes affecting plant strength. Over time, this produced increasingly refined systems of practical plant knowledge. Plants themselves evolved these compounds for their own biological purposes, rather than for human medicine specifically. A bitter chemical discouraging insects from eating leaves might also affect digestion or pain perception in the human body. Aromatic oils protecting plants from pests could influence breathing or skin sensation when prepared correctly. The relationship between plants and humans therefore became connected through biology itself. Ancient ethnobotany reflects one of the earliest ways human beings learned to interact with the chemical systems already existing inside nature. Some compounds proved beneficial within certain contexts, while others became harmful if misused. Ancient communities slowly recognized these differences through repeated experience. A plant helpful in small amounts during illness could become dangerous if prepared improperly or consumed excessively. Knowledge, therefore, remained extremely important for safe use. This practical understanding resembles an early form of toxicology as well as medicine. Ancient people learned that nature contained both healing and dangerous substances, often growing side by side within the same environments. Correct identification and preparation became essential parts of survival. Biology and chemistry remained closely connected throughout these discoveries, even if ancient people described them differently from modern scientists. Plants produced effects because their compounds interacted with living systems inside the human body. Ancient communities observed those interactions directly through lived experience. Modern science now studies many compounds first recognized through traditional plant knowledge. Researchers isolate active substances using advanced chemistry and biology, while investigating how these compounds influence cells, nerves, blood vessels, immune systems, and metabolism. In many cases, scientific research confirms observations ancient people discovered long ago through practical experimentation alone. This connection between past observation and modern science reveals how carefully ancient communities studied the natural world surrounding them. They may not have possessed microscopes or laboratories, yet they still identified meaningful biological effects hidden inside ordinary-looking plants. Across ancient forests, river valleys, deserts, and mountain landscapes, people uncovered a remarkable truth about the living world around them. Beneath leaves, bark, roots, flowers, and seeds existed powerful chemical systems capable of influencing the human body in complex ways. Through observation, caution, patience, and repeated experience, ancient humans gradually transformed this hidden botanical chemistry into some of the earliest foundations of medicine, survival, and biological understanding in human history. As ancient people learned more about the effects plants could produce within the body, they also discovered an important and sometimes dangerous truth about the natural world. Not every plant was safe. Some species provided nourishment, healing, or useful materials, while others caused sickness, confusion, pain, paralysis, or death if handled incorrectly. Ancient ethnobotany therefore involved not only discovering beneficial plants, but also learning how to recognize and avoid harmful compounds hidden within certain species. This knowledge developed slowly through experience, caution, and memory. A community surviving within forests or grasslands could not afford to ignore the dangers surrounding unfamiliar plants. Mistakes carried serious consequences because there were no poison control centers, emergency hospitals, or modern antidotes available. Learning which plants were dangerous became just as important as learning which ones could heal. Imagine walking through a dense ancient woodland filled with berries, roots, flowers, vines, and mushrooms growing beneath the trees. Some may provide valuable nutrition, while others contain powerful toxins invisible to the eye. To ancient people, every unfamiliar plant represented uncertainty. Careful observation and shared knowledge therefore became essential parts of survival. Over many generations, people began recognizing patterns connected to harmful effects. Certain plants caused nausea or weakness. Others affected breathing, heartbeat, balance, or consciousness. Some species irritated the skin, while others became dangerous only after being eaten. Ancient communities learned to distinguish useful plants from harmful ones through repeated observation and experience. This process is how closely connected safety became with preparation and dosage. A plant that proved useful in small amounts might become dangerous in larger quantities. Certain species required drying, heating, soaking, or careful extraction before they could safely be used. Ancient people therefore learned that the effects of plants often depended upon how they were prepared and consumed. This gradual understanding reflects a surprisingly advanced practical awareness of biology and chemistry, even without modern scientific language. Ancient communities recognized that plants contained active substances capable of affecting the body differently depending upon context, concentration, and method of preparation. Knowledge about harmful plants likely spread quickly because communities depended upon remembering dangerous experiences. A poisonous berry or toxic root could threaten entire families if misidentified. Oral traditions therefore became extremely important for preserving warnings alongside healing knowledge. Some plants protected themselves using chemical defenses developed over millions of years of evolution. Bitter compounds, toxins, irritating oils, and powerful alkaloids discouraged animals and insects from consuming them. Ancient humans learned that these same compounds could also affect the human body in significant ways. In some cases, harmful compounds became useful when handled carefully. A toxic plant prepared in extremely controlled amounts might produce medicinal effects unavailable from safer species. Ancient healers, therefore, needed not only knowledge, but also precision and restraint. Small mistakes could transform a useful preparation into something dangerous. This balance between healing and harm appears throughout the history of ethnobotany. Many substances influencing the human body strongly carry both beneficial and harmful potential, depending upon quantity and preparation. Ancient communities learned to navigate this complexity through observation and repeated experience. Biology and chemistry remained connected throughout these discoveries. Plants create compounds for their own survival, rather than specifically for human use. Some chemicals defend against insects or disease, while others regulate growth, scent, or reproduction. When humans encountered these compounds, physical effects sometimes followed in unexpected ways. People also recognized that individuals could respond differently to certain plants. A preparation tolerated well by one person may produce stronger or weaker effects in another. This likely encouraged additional caution when experimenting with unfamiliar species or stronger extracts. There is something remarkable about how much detailed knowledge ancient communities accumulated simply through direct contact with nature. Without laboratories or written scientific systems, people still learn to identify dangerous plants, distinguish similar species, and develop preparation methods, reducing risk while preserving usefulness. The natural world therefore became both provider and warning system simultaneously. Forests and grasslands offered food, medicine, fibers, fuel, and shelter materials, while also containing hidden dangers requiring careful attention. Ancient ethnobotany emerged from this constant interaction between curiosity, necessity, and caution. Communities surviving within different environments developed different understandings of local dangers. A desert culture learned about toxic shrubs and cacti, while tropical societies encountered entirely different species carrying their own chemical defenses. Geography strongly influenced how plant knowledge evolved. This growing awareness of beneficial and harmful compounds also strengthened the role of experienced healers and gatherers inside many societies. People capable of safely identifying plants became valuable because mistakes could affect entire communities. Knowledge itself became a form of protection. Modern science now confirms many observations ancient people discovered through practical experience. Researchers identify toxins, alkaloids, acids, oils, and other active compounds inside plants while studying how they interact with human biology. In many cases, traditional warnings surrounding dangerous species prove remarkably accurate. At the same time, modern pharmacology continues exploring how controlled use of powerful plant compounds may support medicine under carefully regulated conditions. This connection between ancient caution and modern science reveals how deeply early humans studied the natural world surrounding them. Across ancient forests, valleys, wetlands, mountains, and deserts, people learned that nature contained both healing and danger hidden within the same living landscapes. Through patience, memory, caution, and observation, ancient communities uncovered a complex biological world where beneficial and harmful compounds existed side by side, shaping survival, medicine, and humanity's earliest understanding of the powerful chemistry hidden inside plants. While many ancient cultures relied upon plants for food and medicine, plants also formed the physical foundation of daily life through construction, tools, shelter, and material technology. Long before metal buildings, concrete roads, or industrial factories existed, human beings shaped entire civilizations using wood, fibers, reeds, bark, grasses, vines, and other plant materials gathered directly from the natural world. Forests and grasslands became enormous living storehouses, filled with resources capable of supporting homes, transportation, tools, storage, clothing, and survival itself. Ancient people quickly learned that different plant species possessed very different physical properties. Some woods remained dense and durable, while others were light and flexible. Certain fibers twisted easily into strong rope, while others broke apart under pressure. Observation and experience gradually taught communities which plants worked best for particular purposes. Imagine entering an ancient forest with the knowledge that every tree surrounding you might serve a different role within human life. One species could provide strong beams for shelters, while another produced flexible branches, useful for baskets or fishing traps. Tall reeds growing beside rivers might become roofing material, while fibrous bark could be woven into cord or cloth. Ancient people learned to view plants not only as living organisms, but also as structural materials carrying hidden engineering potential. Wood became one of humanity's most important construction resources. Trees provided beams, poles, handles, supports, tools, containers, boats, carts, fences, and fuel for cooking and warmth. Entire settlements often depended upon nearby forests, capable of supplying reliable timber over time. Different woods behaved differently under stress and weather conditions. Some resisted moisture and insects better than others. Certain species remained strong even after years of exposure, while softer woods proved easier to shape and carve into tools or containers. Ancient builders learned which trees worked best for different tasks through repeated practical experience. This understanding reflects a surprisingly sophisticated awareness of natural materials. Ancient people may not have studied molecular structure or material science formally, yet they still recognize strength, flexibility, density, weight, durability, and resistance through observation and experimentation. Fibers became equally important for daily survival. Plants produce fibers as part of their biological structure, and ancient communities learned how to separate, process, twist, weave, and combine these materials into many useful objects. Rope, nets, baskets, sandals, mats, fishing lines, and simple fabrics all depended heavily upon plant fibers. Imagine people sitting together beside a river, carefully twisting damp plant fibers between their hands while creating strong cordage used for tools, traps, shelters, or carrying goods. Such work required patience and experience because different fibers behave differently depending upon moisture, age, preparation, and species. Some fibers remained soft and flexible, while others became coarse and extremely strong. Ancient communities therefore selected materials carefully according to purpose. Fine fibers may have been woven into cloth, while stronger materials supported construction, transportation, or hunting equipment. Preparation methods also mattered greatly. Bark sometimes required soaking before fibers could be separated properly. Certain grasses needed drying, while others worked best when freshly harvested. Ancient people gradually refined techniques, improving strength, durability, and flexibility through repeated practice over generations. Plants therefore shaped not only survival, but also technological development itself. Long before industrial manufacturing existed, human innovation depended heavily upon understanding natural materials and their properties. Ancient engineering emerged directly from observation of the biological world. Different species provided different advantages. Some woods resisted cracking, while others floated well enough for boats or rafts. Flexible vines became natural binding materials, while stiff grasses formed durable roofing surfaces. Ancient builders learned to combine materials together in ways that increased strength and reliability. Environment strongly influenced construction traditions as well. Communities living within dense forests developed different building techniques, from people surviving in open grasslands or dry desert regions. Geography determined which species were available, while climate influenced how materials weathered over time. Plant materials also allowed ancient people to adapt creatively to difficult environments. Flexible shelters could be built from reeds near wetlands, while bark and timber supported colder forest communities. Even temporary camps often depended heavily upon quickly gathered plant materials for protection and comfort. Ancient ethnobotany shows how closely human creativity became tied to biological diversity. Different ecosystems offered different possibilities because every region contained unique combinations of trees, fibers, grasses, reeds, and climbing plants. Human cultures evolved alongside the materials surrounding them. Observation remained central to this process. Ancient people noticed which woods rotted quickly and which remained durable after years of use. They learned which fibers absorbed water, which resisted tension, and which became brittle under heat or sunlight. This growing body of practical knowledge slowly formed the foundation of traditional construction and material craftsmanship. Modern material science now explains many of these differences through cellular structure, moisture content, lignin concentration, fiber arrangement, and chemical composition. Ancient communities lacked this scientific terminology, yet they still recognized material properties with remarkable accuracy through direct experience alone. The relationship between humans and plant materials therefore became connected to survival, architecture, transportation, technology, and everyday comfort. Forests and fields were not passive scenery. They were living systems filled with structural resources, waiting to be understood and shaped through human skill. Across ancient landscapes throughout the world, people slowly transformed wood, bark, reeds, grasses, and fibers into shelters, tools, rope, boats, baskets, and countless objects supporting daily life. Through patience, observation, craftsmanship, and experience, ancient communities uncovered the remarkable engineering potential hidden within plants, building entire ways of life from the biological materials growing naturally around them. As ancient communities gained more experience working with plant materials, they gradually discovered that different woods, fibers, and grasses possessed unique structural qualities, affecting how they could be used in construction and daily life. Some woods remained hard and durable for many years, while others bent easily without breaking. Certain plant fibers stretched under tension, while others became rigid and brittle. Through observation and practical experience, ancient people slowly developed a detailed understanding of natural materials that allowed them to build stronger shelters, tools, boats, storage containers, and transportation systems suited to their environments. This growing knowledge formed one of the earliest foundations of practical engineering. Long before formal architecture or material science existed, people were already selecting plant materials according to strength, flexibility, weight, durability, and resistance to weather. Ancient builders learned that structure itself influenced usefulness because every plant species carried different biological properties shaped by growth patterns and environmental conditions. Imagine an ancient craftsperson standing among stacks of cut wood beside a riverside settlement. One pile contains heavy timber, resistant to moisture and insects. Another consists of lighter, flexible branches, suitable for woven walls or fishing equipment. Nearby reeds dry beneath the sunlight, while bundles of bark fibers wait to be twisted into rope. Every material has a different purpose, because ancient people understood that selecting the right plant often determined whether a structure survived harsh weather or failed under pressure. Durable woods became especially valuable for shelters, support beams, boats, bridges, fences, and storage structures expected to last many seasons. Hardwoods from slow-growing trees often resisted rot, cracking, and insect damage more effectively than softer species. Communities therefore learned to preserve important tree species because reliable construction materials directly affected survival and stability. Flexibility also carried enormous importance. Not every structure benefited from rigid, heavy materials. Lightweight, flexible woods could bend during strong winds without snapping. Thin branches woven together created walls, baskets, fish traps, roofing supports, and carrying frames that remained strong while using relatively little material. Ancient people realized that combining materials often produced better results than relying upon one resource alone. Strong wooden frames could support woven reed walls. Flexible fibers bound heavier beams together. Bark coverings protected structures from rain, while grasses insulated roofs against heat or cold. Human craftsmanship increasingly depended upon understanding how different plant materials behave together under stress and changing weather conditions. This practical knowledge developed slowly through repeated experimentation and observation. A shelter, collapsing during storms, might encourage stronger support designs in the future. Boats made from unsuitable wood may crack or absorb too much water. Communities learned from these experiences and refined techniques gradually over many generations. Structure influenced use in nearly every aspect of ancient life. A dense, heavy wood ideal for tools might prove difficult for carrying or shaping into lightweight objects. Softer woods easier to carve may wear down too quickly under heavy use. Ancient communities therefore balanced many practical considerations when selecting plant materials. Environment strongly shaped these choices as well. Forest cultures surrounded by large timber trees developed very different architectural traditions from desert communities relying upon reeds, grasses, palms, or sparse shrubs. Wet climates demanded materials resistant to moisture, while dry regions favored plants surviving intense sunlight and limited water. Some ancient societies became extraordinarily skilled at using local plant resources efficiently. Boats carved from single tree trunks traveled rivers and coastlines. Flexible bamboo structures survived strong winds in certain regions. Reed houses near wetlands provided insulation and lightweight shelter materials. Human ingenuity adapted continuously to the biological possibilities available within different ecosystems. Ethnobotany shows how connected natural structure became with technological development. Ancient engineering emerged directly from close observation of living organisms. Trees, vines, grasses, bark, and fibers all offered lessons about strength, flexibility, tension, and resilience. People also understood that age and condition influenced material quality. Young wood might bend easily, while older timber became harder and stronger. Fibers harvested too early could weaken quickly. Seasonal timing often affected durability because moisture levels changed throughout the year. Observation therefore remained essential even after communities identified useful species. Plant materials supported far more than simple survival. They shaped transportation, architecture, storage, agriculture, fishing technology, hunting tools, household objects, and trade systems. Entire civilizations depended upon reliable access to forests, grasses, reeds, fibers, and durable wood supplies. Modern engineering and material science now explain many of these ancient observations through cellular biology, fiber density, moisture behavior, lignin structure, elasticity, and mechanical stress. Ancient communities lacked this vocabulary, yet their practical understanding often proved remarkably accurate through direct experience alone. How sustainable many ancient systems remained for long periods of time. Communities relying upon renewable plant resources often developed harvesting traditions, protecting future supplies. Knowledge about forests and seasonal growth became closely tied to long-term survival and environmental awareness. Plants therefore supported construction, not only physically, but intellectually as well. Human beings learned principles of balance, tension, flexibility, and durability through continuous interaction with the natural materials surrounding them. Nature itself became one of humanity's earliest teachers in engineering and design. Across forests, wetlands, coastlines, mountains, and grasslands through history, people slowly transformed living plant materials into shelters, boats, tools, woven structures, and systems of architecture adapted to local conditions. Through patience, craftsmanship, and careful observation, ancient communities uncovered the remarkable structural possibilities hidden inside wood, fibers, reeds, and grasses, shaping the physical foundations of civilization from the biological materials growing naturally across the earth. As ancient societies continued learning how to work with plant materials, fibers gradually became some of the most important resources in daily life. Long before synthetic fabrics, industrial weaving machines, or modern clothing existed, people relied upon fibers gathered from bark, grasses, reeds, leaves, stems, and other plant tissues to create textiles, rope, nets, baskets, mats, sandals, fishing equipment, and protective clothing. Through patience and repeated experimentation, ancient communities slowly transformed fragile strands of plant material into strong woven structures, supporting survival and comfort across many different environments. At first glance, plant fibers may appear delicate and easily broken, yet ancient people discovered that when fibers were twisted, braided, woven, or layered together correctly, they could become remarkably durable. Thin strands gathered from bark or leaves could eventually form ropes capable of carrying heavy loads, woven mats resistant to wear, or cloth soft enough to provide warmth and protection. Imagine sitting beside a quiet riverside settlement long ago, while people patiently separate fibers from long plant stems beneath the afternoon sunlight. Nearby, bundles of reeds dry beside woven baskets, while others twist damp fibers carefully between their fingers to create cord strong enough for fishing nets or shelter construction. Such work required time, rhythm, and experience because the strength of the final material depended heavily upon preparation and technique. Different plants produced very different kinds of fibers. Some species created soft, flexible strands useful for clothing or fine weaving, while others produced coarse, durable fibers better suited for rope, baskets, or structural binding. Ancient people learned which materials worked best for different purposes through direct practical experience. This growing knowledge became connected with comfort and protection. Woven plant fibers allowed people to create coverings shielding the body from sunlight, cold weather, wind, rough surfaces, and insects. In many regions, textile development significantly improved survival by helping communities adapt to difficult climates. Preparation often required considerable effort before fibers became useful. Bark might need soaking in water until softer layers separated properly. Certain grasses required drying, while others worked best when processed fresh. Fibers sometimes needed pounding, combing, scraping, or twisting before weaving could even begin. Ancient communities gradually refined these methods over many generations. Small improvements in preparation techniques could greatly increase flexibility, softness, or strength. Experience taught people how moisture, drying time, plant age, and harvesting season influenced final material quality. Weaving itself became one of humanity's oldest and most widespread technologies. By crossing fibers over and under one another repeatedly, ancient people created larger stable surfaces from small flexible strands. This simple principle allowed the development of cloth, baskets, mats, sails, carrying bags, roofing materials, and countless other useful objects. Plant fibers also supported fishing, agriculture, transportation, and trade. Nets woven from strong fibers improved food gathering, while rope and cord supported shelters, traps, boats, and carrying systems. Entire economies in some regions depended heavily upon textile production and woven goods created from local plant resources. Environment strongly influenced which fibers became important within different cultures. Wetland communities often relied heavily upon reeds and rushes, while forest societies used bark fibers and inner tree layers. Tropical regions developed techniques using palms, grasses, and leaf fibers, while colder climates relied upon entirely different plant species adapted to harsh weather. Ancient textiles is how closely practical function became connected with beauty and identity. Woven materials often reflected local traditions, cultural symbols, regional resources, and craftsmanship passed through generations. Functional objects gradually became expressions of artistic skill as well as survival technology. People also recognized that fibers behave differently under tension, moisture, heat, and repeated use. Some materials shrank when dried while others became stronger after twisting. Certain fibers resisted water damage, while others softened easily. This growing awareness of material properties resembled an early form of practical engineering developed entirely through experience. Plant fibers therefore became more than simple raw materials. They represented adaptable biological structures capable of being transformed into countless useful forms through human creativity and labor. Ancient ethnobotany included not only identifying plants, but also understanding how to process and reshape their hidden structural potential. Modern science now explains many of these fiber properties through cellular arrangement, cellulose structure, moisture behavior, tensile strength, and plant biology. Ancient communities lacked this scientific language, yet their practical understanding often achieved remarkable sophistication through direct contact with natural materials. Textiles also strengthened social and economic systems within many cultures. Skilled weavers and craftspeople became highly valued because quality woven materials affected clothing, shelter, storage, transportation, and trade. Knowledge about fibers therefore carried both practical and cultural importance. How sustainable many ancient fiber systems remained. Communities often harvested renewable plant resources seasonally, while preserving long-term access through careful gathering traditions. Knowledge about local ecosystems remained connected to material production. Plants supported nearly every aspect of ancient daily life, and woven materials became one of the clearest examples of human creativity emerging directly from interaction with nature. Thin strands gathered from forests, riverbanks, grasslands, and wetlands gradually became clothing, baskets, rope, nets, sails, mats, and structures supporting civilization itself. Across ancient landscapes throughout the world, people slowly transformed bark, reeds, grasses, leaves, and stems into durable woven materials through patience, repetition, and craftsmanship. Through careful observation of the natural world, ancient communities uncovered the hidden structural possibilities inside plant fibers, creating textiles and woven technologies that shaped comfort, survival, trade, and culture across human history. As ancient knowledge of plants continued developing across the world, communities realized that the resources available in one environment could differ dramatically from those found in another. Forests, grasslands, deserts, mountains, wetlands, river valleys, and tropical regions all supported different species shaped by climate, rainfall, soil, and geography. Because of this, plant use varied widely between cultures, and over time the natural environment itself began shaping traditions, technology, clothing, architecture, trade, and daily life in profound ways. Ancient people could only work with the plants growing around them or obtained through trade and travel. A community surrounded by dense forests possessed very different resources from people living beside dry desert landscapes or wind-swept grasslands. Geography therefore influenced not only survival, but also the entire development of culture and material technology. Imagine traveling slowly across ancient landscapes thousands of years ago. In one region, tall forests provide abundant timber, bark fibers, nuts, berries, and medicinal herbs growing beneath heavy shade. Farther away, wetlands offer reeds, rushes, water plants, and flexible grasses, ideal for weaving and lightweight shelter construction. Beyond that, dry desert regions support hardy shrubs, drought-resistant plants, and strong fibers adapted to intense heat and limited water. Each environment teaches different skills because each ecosystem offers different possibilities. This relationship between geography and plant use became one of the most important forces shaping early human civilization. Communities adapted their lifestyles according to the materials available around them. Local plants influenced shelter design, food preparation, medicine, transportation, tools, clothing, and even social customs passed through generations. Techniques also developed gradually over time as people refined methods suited to their environments. Forest cultures learned how to split timber, shape wood, and process bark fibers efficiently. Wetland communities perfected weaving techniques using reeds and grasses. Tropical societies developed knowledge surrounding palms, vines, and flexible plant materials, while colder northern regions relied heavily upon durable woods, mosses, roots, and thick insulating fibers. Environment also influenced which plants became culturally important. A tree species providing strong timber and reliable medicine may eventually hold special significance within one society while remaining completely unknown elsewhere. Certain fibers or dye plants could shape regional craftsmanship and trade networks for centuries. Climate played a major role in these differences. Warm, humid regions supported entirely different plant life from cold, mountainous areas or dry deserts. Rainfall patterns influenced which species thrived, while temperature affected growth cycles, harvest timing, and durability of materials. Soil conditions shaped plant distribution as well. Rich, fertile valleys supported species unavailable in rocky mountain terrain or nutrient-poor deserts. Ancient communities learned to recognize these patterns because successful gathering, cultivation, and survival depended upon understanding local ecology. Ethnobotany shows how strongly environmental conditions influenced cultural identity itself. Clothing styles, shelter designs, woven materials, medicinal traditions, and food preparation methods often reflected the specific plants available within local ecosystems. Communities living near rivers frequently developed technologies based around reeds, flexible woods, and water-resistant fibers. Mountain cultures relied upon cold-resistant species capable of surviving difficult weather. Coastal societies incorporated salt-tolerant plants and driftwood resources into daily life. Nature shaped human possibility continuously through geography and biological diversity. Trade gradually expanded these relationships by allowing plant materials and botanical knowledge to travel between regions. Spices, fibers, dyes, medicinal herbs, oils, wood, and seeds moved along ancient trade routes, connecting distant cultures. As people encountered unfamiliar plants, they often adapted foreign knowledge into local traditions. This exchange helped broaden understanding of the natural world while increasing cultural complexity. A medicinal plant valued in one region might eventually become important thousands of miles away after traders introduced it to new communities. Botanical knowledge therefore spread alongside migration, commerce, and exploration. How adaptable human beings became when interacting with different environments. Ancient communities rarely viewed landscapes as empty spaces. Instead, forests, rivers, mountains, wetlands, and grasslands were understood as living systems filled with useful resources waiting to be recognized through experience. Resources shaped culture because available materials influenced what people could build, wear, trade, cultivate, and preserve. A society rich in durable timber developed differently from one dependent primarily upon reeds or grasses. Even artistic traditions and decorative objects often reflected the plants surrounding daily life. Modern ecology and environmental science explain many of these patterns through climate systems, soil chemistry, biodiversity, rainfall distribution, and evolutionary adaptation. Ancient communities lacked scientific terminology, yet they recognized environmental relationships with remarkable practical accuracy. Plants therefore connected biology, geography, technology, and culture together into one continuous system. Ancient ethnobotany reveals how deeply human civilization depended upon understanding local ecosystems and adapting creatively to the resources nature provided. The development of regional plant traditions also strengthened community memory. Families and elders passed down detailed knowledge about where certain plants grew, when they should be harvested, how weather influenced quality, and which species remain most valuable during difficult seasons. Environmental knowledge became inseparable from survival itself. Across forests, deserts, wetlands, coastlines, mountains, and river valleys through history, human cultures evolved alongside the plant life surrounding them. Through patience, observation, adaptation, and shared experience, communities transformed local resources into systems of medicine, shelter, textiles, tools, trade, and tradition, allowing geography and biology together to shape the development of civilizations across the ancient world. As ancient societies developed more advanced weaving, clothing, and decorative traditions, people gradually discovered that many plants also contained hidden pigments capable of producing color. Leaves, bark, roots, berries, flowers, seeds, and even certain woods could release dyes when crushed, soaked, heated, or fermented correctly. Over time, ancient communities transformed these natural pigments into vibrant colors used for textiles, baskets, ceremonial objects, artwork, trade goods, and symbols of cultural identity. At first, these discoveries may have happened accidentally. Crushed berries staining the hands, bark darkening water after long soaking, certain flowers leaving traces of color on woven fibers or animal skins. Ancient people slowly realized that plants carried not only useful fibers and medicine, but also hidden chemical compounds capable of permanently changing appearance. Imagine a quiet settlement beside a river where woven cloth hangs drying beneath warm sunlight after being soaked in colored plant extracts. Nearby, bundles of roots simmer slowly in clay vessels, while craftspeople stir dark liquid carefully with wooden tools. Around them, baskets filled with leaves, flowers, bark, and berries wait to be processed into pigments gathered through generations of experience and experimentation. Different plants produced very different colors. Some roots released deep reds or warm orange tones, while certain leaves created softer greens or yellow shades. Berries and flowers sometimes produced bright temporary colors, while bark and wood extracts often generated darker earthy tones capable of lasting much longer after treatment. Ancient people learned that extracting color required patience and preparation. Simply rubbing plants onto fabric rarely produced durable results. Fibers often needed soaking, heating, repeated washing, or treatment with minerals and ash before pigments bonded properly to woven materials. This understanding resembled an early form of practical chemistry, built through observation and repeated experimentation. Ancient craftspeople recognized that temperature, water quality, timing, and preparation methods all influenced how dyes behaved. Small changes during preparation could dramatically affect the final color. Certain plants became highly valued because their pigments produce strong or rare colors difficult to obtain elsewhere. Communities possessing reliable dye plants sometimes developed important trade networks, supplying colored textiles and pigments to distant regions. Color therefore became connected not only with beauty, but also with economics, status, and cultural exchange. Extraction methods varied greatly depending upon the species involved. Some pigments released easily into hot water, while others required crushing, fermentation, or prolonged soaking. Ancient communities learned which preparation methods produced the richest and most durable results. Heat became especially important in many dyeing traditions. Warm temperatures often helped release compounds hidden inside bark, roots, or leaves, while also allowing pigments to bond more effectively with fibers and textiles. Ancient people lacked molecular chemistry, yet they recognized that preparation conditions changed outcomes significantly. Color variation also depended heavily upon species differences. Closely related plants growing in different environments sometimes produce surprisingly different shades due to soil conditions, rainfall, climate, and plant chemistry. Ancient craftspeople therefore selected materials carefully according to desired results. Plant dyes influenced daily life in many ways beyond simple decoration. Colored textiles identified communities, social roles, ceremonies, and trade goods. Certain shades may have become associated with particular traditions or symbolic meanings within specific cultures. Natural pigments therefore shaped cultural identity as well as visual appearance. Fibers used in weaving also affected how dyes behaved. Some materials absorbed pigments deeply, while others faded more quickly or produced softer tones. Ancient people gradually matched particular dye plants with fibers known to produce stable and attractive combinations. Ancient ethnobotany shows how closely artistic expression became connected with biology itself. The colors decorating textiles, baskets, clothing, and ceremonial objects all originated from chemical compounds produced naturally inside living plants. Plants evolved these pigments for their own biological purposes. Some compounds attracted pollinators, while others protected leaves from sunlight or environmental stress. Ancient humans discovered that these same substances could also transform ordinary fibers and materials into richly colored objects, carrying cultural and artistic meaning. The level of experimentation ancient communities achieved without formal laboratories or scientific instruments. Through repeated observation alone, people learned how to extract pigments, stabilize colors, combine materials, and preserve dyed textiles over long periods of use. Trade helped spread dye knowledge across distant regions as well. Rare pigments and colored fabrics became valuable exchange goods traveling across ancient trade routes. Communities introduced unfamiliar plants and dyeing techniques to one another, expanding artistic traditions over many generations. Modern chemistry explains many of these ancient observations through pigment molecules, tannins, flavonoids, anthocyanins, and other plant compounds influencing color and chemical bonding. Ancient people lacked this terminology, yet their practical understanding often proved surprisingly effective through direct experience and careful experimentation. Natural dyes also reflected local environments strongly. Desert cultures worked with entirely different pigment plants than rainforest societies or northern forest communities. Geography therefore shaped artistic traditions just as strongly as it shaped medicine, shelter, and food systems. Across ancient landscapes throughout the world, people uncovered the hidden colors stored inside leaves, bark, flowers, berries, roots, and wood. Through patience, heat, water, observation, and craftsmanship, ancient communities transformed natural pigments into textiles, artwork, ceremonial objects, and trade goods, allowing the chemistry of living plants to shape human expression, identity, and beauty across thousands of years of history. As ancient people gained more experience working with plant dyes, they gradually discovered that creating stable and lasting colors depended upon far more than simply crushing leaves or soaking fibers in pigment. Temperature, water quality, timing, preparation methods, and even weather conditions could all influence the final appearance of a dyed material. Through patience and repeated experimentation, ancient communities uncovered a remarkably detailed practical understanding of how natural chemistry shaped color. Some dyes released their pigments quickly, while others required long periods of soaking or heating before color appeared fully. Certain roots needed slow boiling over steady firelight, while delicate flowers produced better results in cooler water. Ancient craftspeople learned that preparation itself often determined whether colors became bright, dull, long-lasting, or temporary. Imagine standing beside a quiet fire near an ancient weaving settlement, while clay vessels filled with bark, roots, leaves, and fibers warm slowly over glowing embers. Steam rises gently into the evening air as people stir dark liquid carefully with wooden tools while watching subtle changes in color. Nearby, woven cloth hangs drying beneath fading sunlight after hours of soaking inside carefully prepared dye baths. Every stage of the process reflects knowledge gathered slowly through generations of observation and practice. Temperature became one of the most important factors in ancient dyeing traditions. Heat often helped release pigments trapped inside plant tissues, while also allowing color compounds to bond more effectively with woven fibers. Yet too much heat could damage certain dyes completely, causing colors to fade, darken unexpectedly, or lose intensity. Ancient people therefore learned to control fire and preparation carefully. Some dye materials required gentle warming for many hours, while others depended upon stronger boiling temperatures. Different species responded differently, depending upon the compounds hidden inside their roots, bark, flowers, or leaves. Water quality also influenced results in significant ways. Minerals dissolved naturally in river water, spring water, or well water could change how pigments reacted during preparation. Ancient communities lacked formal chemistry, yet they recognized that identical plants sometimes produce different colors when prepared in different locations. Preparation methods varied widely between cultures and environments. Some communities fermented plant material before dyeing, while others dried roots or bark carefully for later use. Certain pigments worked best when combined with ash, clay, oils, or mineral-rich substances collected from the local landscape. Ancient people learned that many natural dyes bonded poorly to fibers unless additional materials helped stabilize the pigments. Ashes from burned wood, mineral-rich mud, salts, or metallic compounds sometimes improved how colors attached to woven textiles. Although ancient craftspeople lacked molecular explanations, they clearly recognized that chemical interactions influenced final results. This practical knowledge resembled early experimental chemistry, built through observation and repetition. Communities remembered which combinations worked reliably, while less successful methods gradually disappeared through experience. Colors themselves could change dramatically depending upon preparation. The same plant might produce yellow under one condition, yet appear orange, brown, or greenish under another. Temperature, soaking time, acidity, sunlight exposure, and fiber type all influenced appearance in subtle but important ways. Plant species also differed greatly in chemical complexity. Some produced stable pigments resistant to fading, while others created delicate colors, disappearing quickly under sunlight or repeated washing. Ancient communities gradually identified which plants generated reliable dyes, valuable enough for long-term textile production and trade. Natural dyes therefore became connected with craftsmanship and patience. Producing strong, lasting color often required multiple stages of preparation, spread across many hours or even days. Fibers may have been cleaned, soaked, dyed repeatedly, dried carefully, and treated again before the final material reached the desired appearance. How closely this process connected art with biology and chemistry simultaneously. Every color emerging from an ancient dye bath originated from compounds produced naturally inside living plants through their own evolutionary survival processes. Some pigments evolved to attract pollinators, while others protected plants from sunlight or environmental stress. Ancient humans discovered how to transfer these biological colors onto textiles, baskets, leather, wood, and ceremonial objects through carefully controlled preparation techniques. The use of plant dyes spread widely because colored materials held practical, artistic, and cultural importance. Clothing, woven mats, baskets, ceremonial fabrics, and trade goods often carried colors identifying communities, traditions, or social roles. Certain pigments became highly valued because they were rare, difficult to produce, or unusually stable over time. Trade routes helped spread dye knowledge between distant cultures as well. Travelers introduced unfamiliar pigment plants and preparation methods into new regions, expanding the range of colors and techniques available across the ancient world. Modern chemistry now explains many ancient observations through concepts involving acids, tannins, pigment molecules, oxidation, heat reactions, and chemical bonding between dyes and fibers. Ancient communities lacked this vocabulary, yet their practical understanding often achieved extraordinary sophistication through careful observation alone. Plants therefore influenced human creativity, not only through structure and medicine, but also through color itself. Ancient ethnobotany reveals how deeply biological processes shaped visual culture, artistic expression, and technological experimentation across human history. As ancient societies continued developing relationships with the plants surrounding them, many species gradually became connected not only with survival and practical use, but also with rituals, traditions, symbolism, and cultural identity. Certain plants were valued because they healed illness or provided useful fibers, while others gained importance through spiritual meaning, seasonal ceremonies, community customs, or associations with memory and belief. Over time, plants became deeply woven into the emotional and symbolic life of human civilization. This connection emerged naturally because ancient people lived much closer to the rhythms of nature than most modern societies do today. Seasonal changes directly affected food supplies, weather patterns, migration, agriculture, and survival itself. Plants flowered, produced fruit, shed leaves, or disappeared according to cycles that shaped everyday life. Communities therefore began attaching meaning to particular species linked with renewal, protection, fertility, endurance, or remembrance. Imagine a quiet gathering long ago beside a fire at the edge of a forest settlement. Bundles of aromatic plants rest near woven baskets, while leaves and flowers collected earlier that day are prepared carefully for a seasonal ceremony repeated across many generations. Elders speak softly, while younger members of the community observe the traditions surrounding certain plants, known not only for practical value, but also for symbolic importance within the culture itself. Some plants became associated with healing and protection because they repeatedly supported survival during illness or hardship. Others symbolized abundance due to reliable harvests or long life, because certain trees survived for centuries. Fragrant herbs, flowering species, or rare plants sometimes gained ceremonial importance because they stood apart from ordinary daily resources. Cultural meaning often depended heavily upon local environment and tradition. A tree considered sacred within one region may hold little significance elsewhere simply because different ecosystems shaped different relationships between people and plant life. Geography therefore influenced symbolic traditions just as strongly as it influenced medicine, shelter, and food systems. Plants also played important roles during rites connected to birth, adulthood, marriage, harvest, mourning, or seasonal change. Leaves, flowers, oils, smoke, fibers, and wood could all become part of ceremonies reinforcing social identity and shared memory within communities. Ethnobotany shows how closely biological properties sometimes influenced symbolic meaning. A strong, long-lived tree might represent endurance. Fragrant herbs associated with preservation or cleansing may become linked with protection and purification. Plants producing unusual colors or powerful effects often gained special cultural importance because they seem distinct from ordinary species. Ancient people carefully observed these characteristics and gradually connected them with stories, customs, and traditions passed through generations. Over time, practical knowledge and symbolic meaning often became deeply intertwined. Some ritual plant uses may also have originated from practical experience. Aromatic smoke, discouraging insects, could eventually become associated with cleansing ceremonies. Plants easing stress or discomfort may gain importance during spiritual gatherings or healing traditions. Ancient communities rarely separated practical biology completely from symbolic meaning, because both emerged together through lived experience. Knowledge surrounding ritual plants was often preserved carefully through oral traditions and community teaching. Certain species may only have been gathered during specific seasons or prepared according to long-established customs. This helps strengthen continuity between generations while protecting important cultural practices. Plants could also symbolize relationships between humans and the natural world itself. Ancient societies depended heavily upon healthy ecosystems for survival, and many traditions reflected respect, caution, gratitude, or awareness toward forests, rivers, grasslands, and seasonal cycles, providing essential resources. Different species became valued for different reasons. Some carried beauty through flowers or fragrance, while others inspired respect because of strength, rarity, or powerful medicinal effects. Plants influencing emotion, memory, or physical sensation often gained especially strong symbolic roles within rituals and community identity. Trade and cultural exchange helped spread some traditions between distant societies as well. Aromatic resins, herbs, flowers, oils, and rare woods moved across trade routes carrying both practical and ceremonial importance. As cultures encountered unfamiliar plants, they sometimes adopted new meanings and customs connected with those species. How enduring many of these traditions became. Even today, modern cultures continue using flowers, herbs, evergreen branches, aromatic plants, oils, and symbolic trees during holidays, ceremonies, remembrance, and seasonal celebrations. Ancient relationships between plants and meaning still remain visible throughout human life. Modern anthropology, ethnobotany, and biology now study these traditions in greater detail, exploring how plant chemistry, ecology, psychology, and cultural history interacted over time. Researchers increasingly recognize that practical use and symbolic meaning often evolve together rather than separately. Plants therefore shaped human society in ways extending far beyond food, medicine, and construction alone. They influenced emotional life, artistic expression, memory, spirituality, social identity, and cultural continuity across countless generations. The relationship between culture and biology became connected through these traditions. A plant's scent, appearance, strength, rarity, or medicinal effect could all contribute to the symbolic role it eventually carried within a society. Ancient ethnobotany reveals how human beings interpreted the living world not only through survival needs, but also through meaning and shared experience. Across forests, mountains, deserts, river valleys, and grasslands through history, people slowly transformed plants into symbols woven deeply into rituals, customs, ceremonies, and collective memory. Through observation, tradition, and repeated cultural practice, ancient communities allowed leaves, flowers, roots, wood, and fragrant herbs to shape identity, belief, comfort, and human expression across thousands of years of civilization. As plant knowledge expanded across ancient societies, communities gradually built entire systems of tradition, cooperation, trade, healing, craftsmanship, and daily survival around the natural resources surrounding them. Plants influenced far more than food or medicine alone. They shaped how people organized labor, taught younger generations, built homes, created clothing, prepared rituals, exchanged goods, and understood the landscapes they inhabited. Over time, plants became deeply woven into the structure of society itself. Knowledge about useful species rarely belonged to one individual alone. Entire communities participated in gathering, preparing, storing, weaving, building, cultivating, and preserving plant resources across changing seasons. Elders shared experience while healers refined medicinal preparation. Craftspeople improved weaving and construction techniques. Families taught children how to recognize useful species growing near rivers, forests, grasslands, or mountainsides. Imagine an ancient settlement during harvest season, where groups of people moved together through surrounding landscapes, gathering roots, fibers, bark, seeds, and medicinal herbs known through generations of memory. Some carry woven baskets filled with reeds, while others dry leaves carefully beside cooking fires or split wood for tools and shelter repairs. Every task depends upon shared understanding, developed slowly through community experience. Traditions help preserve this knowledge across time. Gathering seasons, preparation methods, storage techniques, and planting practices often followed established customs, repeated year after year. Communities relied upon memory and repetition because survival depended upon maintaining reliable access to food, medicine, fibers, fuel, and building materials. Plants therefore became connected to social organization. Some individuals specialized in healing, while others focused on weaving, construction, agriculture, dye preparation, or ceremonial traditions involving important species. Knowledge itself became a valuable resource shaping status, responsibility, and cooperation within ancient societies. Ethnobotany shows how biological resources gradually influence the growth of culture itself. A region rich in durable timber might support larger permanent settlements, while fertile valleys encouraged agriculture and population growth. Wetlands filled with reeds and grasses could support weaving traditions and trade networks built around textiles and baskets. Environment shaped opportunity continuously. Ancient communities adapted their social structures according to the resources available around them. Seasonal plant cycles influence labor patterns, migration, storage systems, trade relationships, and even ceremonial calendars tied closely to harvest and growth periods. Plants also strengthened relationships between neighboring groups through exchange and trade. Valuable fibers, dyes, medicinal herbs, oils, spices, resins, timber, and woven goods often traveled long distances between communities. As trade expanded, botanical knowledge spread alongside materials themselves. A community living within dense forests may exchange durable timber or medicinal bark with people from dry grasslands, producing woven fibers or rare pigments unavailable elsewhere. Over time, these exchanges encouraged cultural interaction and broader understanding of unfamiliar species and preparation methods. Traditions surrounding plants often became closely tied to identity as well. Particular foods, woven patterns, medicinal practices, or ceremonial herbs could distinguish one culture from another. Plant use therefore reflected both environment and shared social memory. People also understood that protecting valuable plant resources remained important for long-term survival. Some communities developed seasonal harvesting traditions, limiting overuse, while others cultivated useful species near settlements for easier access. Experience taught that careless destruction of forests or useful plants could threaten future generations. This growing awareness reflects an early understanding of sustainability rooted in practical necessity. Ancient societies depended heavily upon renewable biological systems and often learned through hardship when important resources became scarce. Biology and culture remained connected throughout these developments. Human societies adapted themselves continuously to the ecological conditions surrounding them, while simultaneously reshaping landscapes through cultivation, gathering, irrigation, and settlement. Plants also influence communication and storytelling within communities. Knowledge about dangerous species, healing remedies, seasonal harvests, and useful fibers became embedded within oral traditions, passed carefully from elders to younger generations. Stories and customs help preserve practical information while strengthening social bonds. How much human civilization developed through cooperation centered around plant resources. Agriculture required coordinated labor. Weaving and textile production often involved many stages of preparation and craftsmanship. Building shelters from timber and fibers demanded shared effort and accumulated knowledge. Modern anthropology and ethnobotany increasingly reveal how deeply plants shaped economic systems, migration patterns, settlement development, trade routes, and cultural identity throughout human history. Ancient societies cannot be understood fully without recognizing the enormous influence plant resources held over daily life and long-term development. Even today, traces of these ancient relationships remain visible throughout modern culture. Traditional foods, herbal practices, weaving patterns, seasonal festivals, agricultural systems, and regional crafts still reflect plant knowledge accumulated over generations. Plants therefore shaped society not only through survival needs, but through cooperation, memory, labor, trade, identity, and shared tradition. Ancient ethnobotany reveals a world where human communities and local ecosystems evolved together through continuous interaction across countless generations. Across forests, river valleys, coastlines, mountains, wetlands, and grasslands through history, communities slowly built systems of culture and survival around the plant life surrounding them. Through observation, cooperation, tradition, and shared experience, ancient people transformed leaves, roots, fibers, wood, seeds, and medicinal herbs into the foundations of society itself, allowing biology and culture together to shape the development of human civilization across the ancient world. As ancient people traveled across different landscapes and climates, they realized that plants did not grow randomly across the earth. Certain species thrived beside rivers, while others survived only in dry deserts, cold mountains, dense forests, wetlands, or tropical coastlines. Over many generations, human communities began understanding that climate, rainfall, soil conditions, sunlight, elevation, and seasonal patterns all influenced where useful plants could grow and how abundant they became. This growing awareness became extremely important because survival depended heavily upon reliable access to food, medicine, fibers, wood, and other botanical resources. Ancient people learned to observe the environment carefully, recognizing that geography itself shaped which plants appeared within different regions and how those species behaved through changing seasons. Imagine traveling slowly from a humid river valley into dry, rocky hills long ago. The landscape changes gradually around you. Tall, water-loving reeds disappear, while hardier shrubs and drought-resistant plants become more common. Trees growing thickly beside streams thin out across exposed ground, where soil holds less moisture. Ancient people noticed these patterns constantly because their lives depended upon understanding how plant life responded to the environment. Climate became one of the strongest influences shaping vegetation. Warm tropical regions supported entirely different species from colder northern forests or dry desert environments. Rainfall patterns affected plant growth, while long winters, droughts, storms, and seasonal flooding all influenced which species survived successfully within particular ecosystems. Ancient communities gradually recognized that some plants required consistent moisture, while others thrived under intense sunlight and dry conditions. Certain medicinal herbs appeared only during brief seasonal periods, while large trees capable of providing durable timber often required decades or centuries of growth under stable environmental conditions. Soil also played a major role in plant distribution, even if ancient people lacked modern scientific language for nutrients and chemistry. Rich, dark soils near rivers often supported abundant vegetation, useful for agriculture and gathering, while rocky or sandy ground limited which species could survive. Observation allowed communities to predict where valuable species could be found. Knowledge about local geography became inseparable from ethnobotany because plants and environment remained closely connected. Experienced gatherers likely understood subtle environmental details modern people might overlook completely. Elevation changed plant life dramatically as well. Mountain slopes often supported different species at different heights, depending upon temperature, moisture, wind, and sunlight exposure. Ancient travelers moving through mountain regions would encounter shifting ecosystems over relatively short distances. River systems became especially important because water supported rich plant diversity and fertile soil. Many ancient settlements formed beside rivers, partly because those environments provided reliable access to useful vegetation, agriculture, transportation, and fresh water simultaneously. Desert communities developed entirely different relationships with plants. In dry climates, useful species capable of surviving harsh conditions became extremely valuable. Ancient people living in deserts learned how to locate drought-resistant plants, storing moisture, producing fibers, or surviving with minimal rainfall. Forests offered different opportunities and challenges. Dense woodlands supplied timber, bark, medicinal herbs, nuts, berries, and fibers, while also requiring knowledge about navigation, seasonal cycles, and species identification beneath heavy vegetation. Wetlands and coastal regions supported yet another collection of useful species. Reeds, rushes, water plants, salt-tolerant shrubs, and flexible grasses often became important materials for weaving, roofing, fishing equipment, and lightweight construction. Ethnobotany shows how strongly human adaptation depended upon understanding environmental diversity. Ancient communities did not simply gather plants randomly. They learned complex relationships between climate, geography, soil, water, seasons, and plant growth through careful observation accumulated over generations. How accurately many ancient societies understood local ecosystems through direct experience alone. Without maps, satellites, weather forecasts, or ecological science, people still learn to predict seasonal changes, identify fertile ground, and recognize habitats where useful plants thrived reliably. This environmental knowledge shaped migration patterns, settlement choices, agriculture, trade routes, and survival strategies through history. Communities often settled near regions supporting reliable combinations of food plants, construction materials, fresh water, medicinal herbs, and fertile land. Nature guided choices continuously because human survival remained deeply dependent upon ecological conditions. A drought-changing vegetation patterns could influence migration and trade, while fertile valleys supporting abundant plant life encourage population growth and permanent settlement. Modern ecology and environmental science explain these relationships through rainfall distribution, soil chemistry, temperature ranges, biodiversity, sunlight exposure, and evolutionary adaptation. Ancient people lacked this scientific terminology, yet their practical understanding of environmental patterns often proved remarkably sophisticated. Plants therefore connected human life directly to geography itself. Climate shaped vegetation, while vegetation shaped survival, culture, trade, architecture, agriculture, and movement across the ancient world. Ethnobotany reveals how deeply human civilization depended upon learning the hidden environmental rules controlling where useful plants could grow. Across mountains, forests, wetlands, river valleys, deserts, grasslands, and tropical coastlines through history, people uncovered the powerful relationship between geography and plant life. Through observation, travel, memory, and adaptation, ancient communities learned how climate, soil, water, and seasonal patterns shaped the living landscapes surrounding them, allowing environmental knowledge itself to become one of humanity's most valuable survival tools across thousands of years of civilization. As ancient communities continued adapting to the environment surrounding them, plant knowledge became increasingly specialized according to geography, climate, seasonal conditions, and local ecosystems. People living beside cold northern forests developed very different botanical traditions from communities surviving within tropical jungles, dry deserts, coastal wetlands, or high mountain valleys. Over time, ancient ethnobotany evolved into thousands of highly regional systems shaped directly by local landscapes and environmental pressures. This regional adaptation allowed human societies to survive within environments that at first may have seemed difficult or unforgiving. Communities learned which plants provided food during drought, which fibers remained durable in humid climates, which woods resisted freezing temperatures, and which medicinal herbs thrived in rocky mountain soil or river floodplains. Local ecosystems became connected to identity, tradition, and survival. Imagine a family living near a cold northern forest long ago. They recognize subtle differences between evergreen trees, mosses, roots, and shrubs, because generations before them depended upon those species for shelter, warmth, medicine, and food storage during long winters. Far away in a tropical region, another community develops equally detailed knowledge surrounding palms, vines, broadleaf plants, fragrant flowers, and moisture-rich forests filled with entirely different biological resources. Both societies become experts in the ecosystems surrounding them because survival demands careful attention to local nature. Regional plant knowledge often reached remarkable levels of precision. Ancient gatherers understood where certain species grew best, how weather affected potency and growth, which slopes retained moisture longest during dry periods, and which riverbanks supported reliable medicinal herbs year after year. Local experience shaped understanding in ways difficult to separate from daily life itself. This knowledge accumulated gradually through generations of observation. Parents guided children through familiar gathering routes, while elders explained seasonal patterns and environmental changes affecting plant availability. Over time, communities developed sophisticated awareness of local ecology, even without written scientific systems. Different climates encourage very different solutions to survival problems. In cold environments, durable woods, insulating fibers, and long-lasting storage plants became especially important. Desert societies valued drought-resistant species capable of surviving intense heat and limited water. Wetland communities specialized in reeds, rushes, and flexible aquatic plants, while mountain cultures adapted to steep terrain and short growing seasons. Geography therefore shaped not only available resources, but also patterns of thinking and cultural development. A society depending heavily upon large forests developed different traditions, from one relying upon seasonal grasslands or tropical river systems. Nature influenced human behavior continuously through the opportunities and limitations presented by local ecosystems. Communities also learned how to adapt when environments changed unexpectedly. Floods, droughts, storms, wildfires, or shifting climate patterns could alter vegetation and resource availability significantly. Survival often depended upon flexibility and the ability to recognize new opportunities within changing landscapes. Ethnobotany shows how deeply local ecosystems shaped human intelligence itself. Ancient people trained memory, observation, navigation, and practical reasoning through constant interaction with the natural world surrounding them. Knowledge about plants often required recognizing subtle details in color, scent, leaf shape, soil moisture, seasonal timing, and weather patterns. Trade and migration gradually connected these regional traditions together. Travelers carried seeds, fibers, medicinal herbs, dyes, and practical knowledge across long distances. Communities encountering unfamiliar plants often compared new species with those already known within local ecosystems, slowly expanding their botanical understanding through exchange and exploration. Some regions became especially famous for particular plant resources. Certain valleys produced valuable medicinal herbs, while dense forests supplied rare timber or aromatic resins. Coastal wetlands supported weaving traditions built around reeds and grasses, while tropical environments provided spices, oils, fruits, and strong fibers unavailable elsewhere. How sustainable many local traditions became through repeated environmental experience. Ancient communities often developed seasonal harvesting methods, protecting future plant growth, because long-term survival depended upon maintaining healthy ecosystems across generations. Modern ecology and ethnobotany now reveal how closely these traditional systems aligned with environmental realities. Ancient people may not have possessed formal scientific terminology, yet they still recognized biodiversity, habitat variation, seasonal cycles, and ecological balance through practical observation alone. Nature guided countless daily decisions throughout ancient life. Communities learned where to gather safely during drought, when to harvest before seasonal rains, which valleys remained fertile after flooding, and which plants survived difficult winters or dry seasons most reliably. The relationship between humans and local ecosystems therefore became deeply cooperative. Ancient societies depended upon understanding environmental patterns, while plants simultaneously shaped culture, settlement, technology, medicine, and survival strategies across different regions of the world. Regional adaptation also strengthened community identity, because knowledge about local plants often remained unique to specific environments and traditions. Stories, rituals, gathering roots, preparation methods, and ecological observations became part of cultural memory, passed carefully through generations. Across forests, deserts, mountains, wetlands, grasslands, tropical valleys, and coastal regions through history, human communities slowly adapted themselves to the living ecosystems surrounding them, Through observation, memory, migration, and environmental experience, ancient people transformed local plant knowledge into highly specialized systems of survival and culture, allowing geography and biology together to shape countless unique civilizations across the ancient world. As modern science developed during recent centuries, researchers began studying many of the same plants ancient communities had used for generations through observation, experimentation, and traditional knowledge. Chemists, biologists, physicians, botanists, and pharmacologists slowly discovered that numerous plants contained complex compounds capable of influencing the human body in measurable ways. In many cases, scientific investigation confirmed practical observations first made by ancient people long before laboratories or modern medicine existed. This connection between ancient ethnobotany and modern science remains one of the most remarkable examples of knowledge developing across vast stretches of time. Traditional healers and gatherers relied upon direct experience, while modern researchers use microscopes, chemical analysis, genetic study, and controlled experiments. Yet both approaches often focus on the same living organisms and the hidden biological properties contained within them. Imagine an ancient healer gathering bark beside a forest stream because generations of experience associated the plant with reducing pain or fever. Thousands of years later, modern scientists may isolate chemical compounds from that same species while studying how those substances interact with nerves, blood vessels, inflammation, or cellular signaling inside the body. Although the methods differ greatly, both traditions reflect careful attention to the effects plants produce. Modern ethnobotany shows that plants manufacture enormous numbers of biologically active compounds. These substances evolved primarily to support the plant's own survival by discouraging insects, resisting disease, attracting pollinators, storing energy, or adapting to environmental stress. Human beings learned that many of these compounds could also influence human biology in useful ways. Ancient people lacked the scientific vocabulary needed to describe alkaloids, flavonoids, tannins, glycosides, oils, acids, and other chemical compounds. Yet through observation alone, they still recognized patterns connecting certain plants with specific effects on health, digestion, pain, energy, skin irritation, breathing, or sleep. Modern research increasingly reveals how sophisticated many traditional observations actually were. Some plants long valued in ancient medicine contain compounds now used directly or indirectly within pharmaceutical development. Others continue being studied because they influence inflammation, immune response, circulation, bacterial growth, or nervous system activity in measurable ways. Ancient ethnobotany therefore remains scientifically valuable because traditional knowledge sometimes guides researchers toward species worth investigating more closely. Communities interacting with local ecosystems for centuries often accumulated detailed understanding about plant behavior, preparation methods, and biological effects. This does not mean every ancient remedy proves effective under scientific testing. Some traditional practices work poorly, while others may even be harmful. Yet many observations reveal genuine biological interactions worthy of careful modern study. Ethnobotany helps bridge cultural history and biological science together through shared interest in plant life. Modern researchers also recognize that preparation methods used by ancient communities often influenced effectiveness significantly. Drying, heating, fermenting, soaking, grinding, or combining plants with oils and minerals could alter chemical composition and biological activity in important ways. Ancient techniques sometimes reflected practical understanding developed through generations of experimentation. Plants remain essential resources even within highly technological societies today. Modern agriculture depends upon cultivated plant species, while medicine continues studying natural compounds for potential treatments and pharmaceutical development. Fibers, oils, wood, food crops, pigments, and aromatic compounds still shape industries across the modern world. This relationship is how much biodiversity still remains unexplored scientifically. Tropical forests, wetlands, mountains, grasslands, and marine ecosystems contain countless species whose chemical properties remain only partially understood. Ancient ethnobotanical traditions may preserve valuable clues about plants modern science has barely begun studying. How interconnected biology becomes through these discoveries. A compound evolved by a plant for defense against insects may later influence human pain pathways or immune activity. Nature produces extraordinary chemical complexity through evolution, and humans continue learning how these systems interact with the body. Ancient knowledge often emphasized observation and long-term experience rather than isolated experimentation. Communities noticed how plants behaved across seasons, climates, ages, preparation methods, and individual responses. Modern science increasingly values this ecological and practical context when studying traditional botanical systems. Trade, migration, and exploration also helped spread plant knowledge globally over many centuries. Medicinal herbs, spices, seeds, fibers, oils, and dyes traveled between cultures, while botanical traditions expanded through cultural exchange. Modern ethnobotany studies many of these historical interactions alongside biology itself. Technology has dramatically expanded scientific understanding of plants during recent centuries. Microscopes reveal cellular structures, while chemistry identifies active compounds, and genetics explores evolutionary relationships between species. Yet despite these advances, much of the original curiosity driving ethnobotany remains unchanged. Human beings still seek to understand how the living world around them interacts with the body and mind. The relationship between ancient traditions and modern science therefore reflects continuity rather than complete separation. Observation, experimentation, caution, and curiosity remain central to both approaches, even though the tools and explanations differ greatly. Across forests, laboratories, mountains, wetlands, universities, river valleys, and ancient gathering grounds throughout history, human beings have continued studying the remarkable biological properties hidden inside plants. Through memory, experimentation, chemistry, observation, and scientific investigation, ancient ethnobotanical knowledge and modern biology together reveal an extraordinary truth about the natural world, that the living plants surrounding humanity contain immense complexity, still shaping medicine, agriculture, technology, and human understanding across generations. Even within the modern world, filled with advanced technology, massive cities, laboratories, satellites, and industrial systems, human civilization still depends heavily upon plants in ways many people rarely stop to consider. Agriculture, medicine, construction, textiles, food production, paper, oils, fragrances, dyes, and countless manufactured goods all remain connected to the biological resources growing across the earth. Ancient ethnobotany may seem distant at first glance, yet the relationship between humans and plants continues shaping modern life every day. Agriculture forms one of the clearest examples of this dependence. Nearly all human food systems ultimately rely upon cultivated plant species or animals supported through plant-based ecosystems. Grains, fruits, vegetables, legumes, nuts, oils, herbs, and fibers remain essential foundations of civilization, just as they were thousands of years ago. Imagine looking across a modern agricultural valley stretching toward the horizon beneath morning sunlight. Vast fields of crops move gently in the wind, while irrigation systems, harvesting equipment, and storage facilities operate with impressive efficiency. Yet beneath all the technology, the fundamental relationship remains ancient and familiar. Human survival still depends upon understanding how plants grow, reproduce, respond to climate, and interact with soil, water, and sunlight. Ancient communities learn these principles gradually through observation and seasonal experience. Modern agriculture now uses genetics, soil science, climate modeling, and advanced machinery, yet the biological foundations remain closely tied to the same living systems early humans once studied beside rivers and forests. Medicine also continues relying heavily upon plant compounds. Many modern pharmaceuticals either originate directly from plants or were inspired by natural substances first identified through botanical research. Scientists study roots, bark, leaves, flowers, seeds, and marine plants, searching for compounds capable of influencing inflammation, infection, circulation, pain, immunity, or nervous system activity. This connection between ancient remedies and modern pharmacology reveals how deeply nature still shapes medicine. A plant growing quietly within a rainforest or mountain valley may contain molecules affecting human biology in powerful ways despite remaining unknown to science for centuries. Plants also remain essential for materials and industry. Wood continues supporting construction, while fibers contribute to textiles, paper, rope, and composite materials. Oils extracted from seeds and leaves appear in cosmetics, soaps, medicines, fragrances, and food production systems around the world. Even modern energy systems still reflect ancient botanical history. Coal, oil, and natural gas formed partly from ancient plant life, compressed beneath geological pressure across immense stretches of time. In a very real sense, modern civilization continues depending upon biological energy captured by plants millions of years ago through sunlight and photosynthesis. Scientific investigation into plant biology continues expanding rapidly as well. Researchers study genetics, ecology, biodiversity, adaptation, climate resistance, and chemical compounds hidden inside species throughout forests, deserts, wetlands, grasslands, and marine environments. Every year brings new discoveries about how plants interact with ecosystems and human biology. Modern ethnobotany is how much remains unknown. Scientists estimate that many plant species across the world have not yet been studied thoroughly for medicinal or biochemical potential. Tropical forests alone contain extraordinary biological diversity, still only partially understood. Ancient knowledge sometimes guides these investigations because traditional communities may preserve observations accumulated through centuries of interaction with local ecosystems. Researchers increasingly collaborate with indigenous groups and traditional healers whose environmental knowledge remains deeply detailed and regionally specialized. This growing respect for traditional ecological knowledge reflects a broader understanding that observation and long-term experience still hold scientific value. Ancient ethnobotany was not random superstition alone. In many cases, it represented careful practical interaction with biology and ecology across generations. How plants continue supporting life quietly in the background of modern civilization. Every breath depends partly upon oxygen produced through photosynthesis. Every meal connects back to plant-based ecosystems. Even urban populations living far from forests and farms remain deeply dependent upon biological systems sustained by plant life. Climate change and environmental pressure have also increased awareness of how important healthy ecosystems remain for humanity's future. Deforestation, soil degradation, biodiversity loss, and changing weather patterns directly affect agriculture, medicine, water systems, and global ecological stability. Ancient societies often understood this connection through practical necessity because survival depended visibly upon healthy landscapes and reliable plant growth. Modern civilization sometimes appears more separated from nature, yet the dependence remains just as real beneath layers of technology and infrastructure. Scientific research now explores how plants adapt to drought, disease, temperature shifts, and environmental stress. Agriculture increasingly depends upon understanding resilience, biodiversity, and sustainable cultivation methods capable of supporting growing populations under changing conditions. Plants therefore remain central, not only to history, but also to the future of civilization itself. Medicine, agriculture, climate stability, nutrition, construction, manufacturing, and ecological balance all continue relying upon the remarkable biological systems hidden inside leaves, roots, bark, stems, flowers, and seeds. Across laboratories, forests, farms, wetlands, cities, mountains, river valleys, and ancient landscapes throughout the modern world, human beings continue depending upon plants in countless visible and invisible ways. Through science, agriculture, medicine, ecology, and daily survival, the ancient relationship between humanity and the botanical world remains alive, connecting modern civilization directly to the same living natural systems that shaped human culture, health, and survival thousands of years ago. Throughout human history, survival depended heavily upon the ability to observe the natural world carefully and respond intelligently to changing environmental conditions. Ancient people did not possess satellites, laboratories, digital maps, weather forecasts, or modern scientific instruments. Instead, they relied upon memory, attention, pattern recognition, and practical experience gathered through daily interaction with plants, animals, landscapes, seasons, rivers, forests, and climate. Observation itself became one of humanity's most important survival tools. Plants played a central role within this process because they existed everywhere human beings traveled. Forests, wetlands, deserts, grasslands, coastlines, and mountain valleys all contained species capable of providing food, medicine, fibers, shelter materials, fuel, and trade resources if understood correctly. Ancient ethnobotany therefore emerged not from abstract curiosity alone, but from the constant practical need to solve survival problems using the natural world surrounding human communities. Imagine an ancient traveler moving slowly across unfamiliar terrain while paying close attention to every detail in the landscape. Certain plants growing near water may reveal hidden streams nearby. Flowering patterns could signal changing seasons. Trees bent by prevailing winds might help guide direction across open terrain. A cluster of useful herbs appearing along a riverbank could mean the difference between recovery and illness during difficult journeys. Over many generations, human beings became extraordinarily skilled at reading environmental signals hidden within plant life. Leaves changing color, unusual flowering cycles, declining vegetation, or shifting growth patterns all carried information about climate, rainfall, soil conditions, and seasonal timing. Ancient communities learned to interpret these signs because survival depended upon understanding them accurately. This close relationship between humans and nature shaped how people thought about the world itself. Ancient societies often viewed landscapes not as empty scenery, but as living systems filled with meaning, resources, opportunities, and warnings. Forests, mountains, rivers, wetlands, and grasslands were studied constantly through direct experience and observation. Observation allowed ancient communities to solve practical problems continuously. Drought-resistant plants became valuable during dry periods, while certain roots provided emergency food during famine. Fibers supported shelter and transportation, while medicinal herbs eased injury and illness. Human survival remained connected to understanding how local ecosystems functioned. Ethnobotany shows how intelligence developed through repeated interaction with nature itself. Ancient people trained memory, attention, navigation, experimentation, and environmental reasoning by studying the living world surrounding them every day. Knowledge often accumulated gradually through many small observations rather than dramatic discoveries. A community noticing which plants attracted animals during migration seasons. Healers recognizing that one preparation worked more reliably after drying. Builders learning that certain woods resisted moisture better when harvested during colder months. Human understanding expanded slowly through countless ordinary experiences repeated over generations. Ancient ethnobotany also reveals how adaptable human beings became in response to environmental diversity. Communities surviving within dense tropical forests developed different knowledge systems from people living beside cold mountain ranges or dry desert valleys. Nature shaped survival strategies continuously according to geography and climate. Trade and migration expanded these observations further. As travelers encountered unfamiliar plants in distant regions, they compared them with species already known at home. Some plants became highly valued because they solved important problems related to medicine, food preservation, textiles, fragrance, or construction. How ancient observation often aligned closely with modern scientific understanding, despite the absence of advanced technology. Communities identified medicinal effects, seasonal patterns, ecological relationships, and useful preparation methods simply through careful, practical experience over time. Modern science now explains many of these observations through ecology, chemistry, biology, climate science, and environmental systems. Yet the original foundation often remained the same. Human beings watched nature carefully, recognized repeating patterns, and adapted behavior according to those observations. Plants solved countless survival challenges throughout history because they represented renewable biological systems capable of supporting nutrition, healing, shelter, warmth, transportation, storage, and craftsmanship simultaneously. Ancient people learned to work with these systems rather than remaining separate from them. Observation also encouraged patience. Trees required years of growth before becoming useful timber. Seasonal plants appeared only during certain times of year. Fibers needed preparation before weaving, while medicinal roots often required drying or careful extraction. Ancient communities learned to think across longer natural cycles because plants themselves followed rhythms shaped by climate and biology. This relationship between humanity and nature remained deeply cooperative. Plants provided resources, while humans learned how to gather, cultivate, protect, trade, and preserve those resources through increasingly organized systems of knowledge and culture. Modern life sometimes creates the illusion that people exist separately from natural systems, yet human civilization still depends heavily upon ecological stability, agriculture, forests, biodiversity, and plant-based resources supporting food, medicine, climate regulation, and industry around the world. Ancient ethnobotany therefore reveals more than historical survival techniques alone. It reveals a long partnership between human intelligence and the living environment itself. Through observation, experimentation, adaptation, and memory, ancient people learned how to solve problems by studying the biological systems surrounding them. Across forests, deserts, mountains, wetlands, grasslands, coastlines, and river valleys throughout human history, people uncovered patterns hidden within the natural world through patience and careful attention. By observing plants closely and adapting to changing environments, ancient communities transformed nature itself into a source of knowledge, survival, healing, technology, and cultural growth, shaping the development of civilization across thousands of years of human experience. For thousands of years, human civilization has grown beside forests, rivers, grasslands, mountains, wetlands, deserts, and fertile valleys, shaped continuously by the presence of plant life. Long before written history, ancient people learned that survival depended upon understanding the living world surrounding them. Plants provided food during difficult seasons, medicine during illness, fibers for weaving, timber for shelter, fuel for warmth, pigments for art, and materials for trade, ceremony, transportation, and daily life. Over time, these relationships shaped the development of culture itself. What began as simple observation gradually evolved into remarkably detailed systems of ethnobotanical knowledge passed carefully through generations. Ancient people learned how climate influenced growth, how preparation changed plant effects, how different woods behaved under stress, and how hidden compounds inside roots, bark, leaves, flowers, and seeds could influence the body in powerful ways. Through patience and repeated experience, humanity uncovered the extraordinary biological complexity hidden inside the natural world. Imagine standing quietly at the edge of an ancient forest while evening light moves gently across the trees. Around you, generations of human experience seem almost woven into the landscape itself. Paths once used for gathering herbs and fibers disappear into the distance, while riverbanks still support reeds and medicinal plants known long before modern science existed. Forests that once supplied shelter, dyes, tools, and healing preparations continue growing through changing centuries, carrying silent traces of countless human lives shaped by the plant life surrounding them. Ethnobotany shows how gradual this knowledge became. Human understanding did not appear suddenly through one invention or discovery. Instead, it accumulated slowly through observation, experimentation, storytelling, memory, travel, trade, and adaptation across thousands of years. Every generation inherited practical understanding from those who came before them, then added new experiences shaped by changing environments and local ecosystems. Plants therefore became connected not only to survival, but also to culture, identity, craftsmanship, medicine, and social organization. Communities built homes from wood and reeds, wove fibers into textiles, prepared dyes from roots and bark, preserved healing traditions through oral teaching, and shaped ceremonies around species carrying symbolic meaning. Nature influenced nearly every aspect of ancient life. This relationship continues even within the modern world. Agriculture still depends upon cultivated plant systems, while medicine continues studying compounds first discovered through traditional observation and ethnobotanical practice. Forests regulate climate, wetlands support biodiversity, and plant life remains essential for oxygen production, ecological balance, food systems, and human health across the earth. Modern science now reveals the extraordinary complexity hidden inside plants themselves. Chemical compounds produced for defense, growth, communication, or survival can influence human biology in powerful ways. Ecology explains relationships between climate, soil, biodiversity, and vegetation, while genetics explores how species adapt across changing environments. Yet despite these scientific advances, the original human connection to plants remains surprisingly familiar. This partnership between humanity and plant life shaped civilization slowly and continuously. Crops supported permanent settlements, fibers encouraged weaving and trade, durable timber allowed larger structures and transportation systems. Medicinal herbs influenced healing traditions, while dyes and aromatic plants shaped art, ritual, and identity. Human progress emerged partly through learning how to work with the biological systems already existing in nature. How much knowledge ancient communities developed without modern scientific tools. Through observation alone, people identified medicinal effects, ecological patterns, durable materials, seasonal cycles, and preparation methods capable of supporting survival under difficult conditions. Ethnobotany reflects humanity's long ability to learn directly from the natural world itself. At the same time, the story of plants and civilization is still continuing. Modern researchers continue discovering new compounds, ecological relationships, agricultural techniques, and environmental challenges connected to plant biology. Climate change, biodiversity loss, deforestation, and ecological disruption now influence how humanity thinks about sustainability and the future of natural systems supporting life across the planet. Ancient ethnobotanical traditions often carried an important understanding that modern societies sometimes forget. Human beings are not fully separate from nature. Civilization depends upon healthy ecosystems, fertile soil, reliable water, biodiversity, forests, wetlands, and stable climate systems maintained partly through plant life itself. The forests surrounding ancient settlements, the reeds gathered beside rivers, the medicinal herbs dried carefully near firelight, and the fibers woven patiently into cloth all formed part of a much larger relationship between humanity and the living earth. Across countless generations, plants quietly shaped survival, culture, technology, memory, and human imagination. Even now, modern cities remain connected to ancient biological systems through food, medicine, construction materials, paper, textiles, oils, agriculture, and the oxygen produced continuously by forests and plant life across the world. The relationship never truly disappeared. It simply became easier to overlook beneath layers of technology and infrastructure. Across deserts, mountains, tropical forests, wetlands, coastlines, grasslands, and fertile river valleys throughout human history, people learned to observe, gather, cultivate, protect, and understand the plants surrounding them. Through patience, adaptation, memory, experimentation, and shared tradition, ancient communities transformed the natural world into a foundation for civilization itself, allowing leaves, roots, bark, fibers, flowers, and seeds to shape the long story of human survival and cultural development across thousands of years of history. Thank you for listening to the Sleepy Mind channel. I hope you enjoyed learning about the hidden knowledge of ancient ethnobotany and the remarkable relationship between human beings and the plant life surrounding them throughout history.